trying to find, that you're going to end up at different locations at the end. I think that one, there we go.
Yay!
And I noticed that, see, this one might be a little bit too far away. I tried to make a perfect triangle. Now, put in some other locations. Let's see where it lands. Anywhere you want.
Dead center. Dead center.
There you go. Let's watch this. You give it more energy, so it's going to take a while to settle down.
So
Would everybody agree that this is a slightly different sort of an oscillator than we've had in the past, right?
Slightly.
Yeah, try it over here. Give it a lot of energy. Every time it goes through there, it's probably losing. Oh,
interference.
it's okay. That's fine. We all agree, I think, that this will damp out and eventually end up at one of those magnets. Now, here's what we're going to think about. Let's say that we plotted points on the table when the magnet starts above a certain point, let's say. Oh, I want it to go. It's just, it's probably not, it's not balanced nicely. I'm not feeling it. You see where the middle is, Connor? Go ahead.
I don't know, I'm just letting.
Make it so that it's smack dab, if you can make it in the middle.
I think that's dead center. I think it's straight down like there.
And then it just goes to that one.
Wait,
Yeah, you can adjust it. You can adjust it.
I want to just put dead center. Yeah.
Oh, that's good.
There we go. There we go.
So here's when we're doing this, I want you to think about points on the surface of the table.
There we go.
Good. If you release it from rest above a certain point, that point will have the number 1, 2, or 3 on it, right? And then we make a map on the table that shows where it lands depending upon where it starts. That will be a nice kind of picture on the table, wouldn't it? Well, what we're going to do is see what those pictures look like because they are very complicated.
If you release it from the same place.
Well, the thing is, that's what you'll find out that it doesn't. The more closer you look at it, a movement of this little bit will change where it's going to land. And so what we're going to say is these sorts of oscillators have what are known as sensitive dependence on initial conditions. That's the phrase I want you to know today. Sensitive dependence on initial conditions.
I guess this is more theoretical than calculated.
Well, there is a way of kind of dealing with that term, but that's a good way of saying it. I would like to say, too, and you'll see this term, do you ever hear the idea of the straw that broke the camel's back?
Yeah.
That has sensitive dependence on initial conditions.